Good afternoon, everybody. It's a pleasure for me to be here, so I want to spend just a few seconds to say thanks to the organizer for inviting me. By chance, I'm Italian, so I mean, it's not a surprise for me to be in Bologna. I know this city very well, and I'm happy that you are enjoying the city. So actually, Bente, when introduced the session, she said that probably we could have solution or ideas how to stimulate this work together. Actually, I don't have any solution. The idea to come here is because we have already started this discussion within ESFRI among the different strategy working group chairs how to try to tackle this kind of problem together in a more harmonized way. It's not trivial, it's not easy to do. I've learned a lot in the last 2 days. I want to also to show something that we are doing for the environmental research infrastructures, because there are many things in common. So I think that we can also start from the commonalities in order to see how we can try to find the right path towards this kind of assessment of socioeconomic impact for research infrastructures. As in the case for social science, also in the environmental domain, we have very largely distributed research infrastructures, and this makes the typical model for socioeconomic impact assessment not very well established in this case. What we are considering in general is the economic impact, the excellence research and services for society. This is what we should consider for environmental research infrastructures. For the economic impact, I would like to stress the fact that in most of the biggest research infrastructure single sites, you have a sort of strong impact at the beginning during the construction phase. But if we use this kind of models that we are using in the environment, which is the upstream and the downstream, well, for the upstream, we considered, in this sense, I'm just talking about economic impact, investments to really build the research infrastructures, while for the downstream, we consider the investment that can be done starting from the research infrastructures, data, and services. I want just to make an example. IAGOS is a research infrastructure in the environmental domain. It's based on commercial aircraft providing measurements for air quality and climate change in the upper atmosphere. There are some upstream impacts which are clear, that there is a partnership with private companies, with the private sector, in order to develop specific instruments to be allocated on board of these aircraft. And this also means that there are new jobs, for example. But there are also downstream impacts which are related to excellence in research, to provide a platform for users, for scientific users to conduct excellent research, but also to provide data to Copernicus, which is an important program, and also other indirect services for the industry. If I try to summarize what we have collected for all research infrastructure in the environmental domain, I will say that only for the economic impact, we can see that for the upstream impact, we have some investments that we can quantify in terms of money for building the research infrastructures, and also the technical cooperation which is put in place during the construction phase for the research infrastructures. And there is some job creation. But in this case, the private sector in general is mainly seen as a supplier. And what we can evaluate is that this kind of upstream impact, in terms of economic impact, is much lower respect to other domains where you have big installation in a single site research infrastructures. While if we move to the downstream impact, so in terms of capacity building, technological innovation, and later on, we should also consider the services for society and support to policy. Here, the private sector is mainly seen as a user. Then there is a tremendous value for the data, in the open data, so we should also try to quantify the real value of the data, because data can generate innovation, per se. Then there is the socioeconomic impact when the research infrastructure is already in operation, when the services are already implemented. This means that we should consider the time. If you have in mind the life cycle for research infrastructures, we should also have a life cycle for the socioeconomic impact. I mean, if you don't start your services, it's really difficult to have this and to measure. And of course, we need to find a more rigorous criteria to try to quantify some of the societal impact, because those are then related to the economic impact. If we just consider the environment, and then you will see that already in this slide there are a lot of links with other domains. We should consider that many of the most urgent challenges human societies are facing are related to complex interaction with the environment. And here is where the research infrastructures in environmental domain play a key role. I don't want to read everything, but just to say that this can provide not only data but also technical solutions in order to improve the methodologies and solutions for mitigation and adaptation, not only to climate change, because everybody's talking about climate change, but also related to other things which could be related also to climate change, but I would like to report in particular separate things like pollution and hazards and so on, because those are also the things which are raising a lot of concerns in the society so far. And this is also linked to the social science, I would say. It's the perception of the citizen. They live now. They think that this is risky. So I mean, there are many examples that I can show you. I can spend hours to make examples of societal impacts for the different research infrastructures, providing crucial information for climate change, for air quality, for environmental hazards, for supporting policy and so on. But I want also to spend some time to tell you that, I mean, yesterday Milena mentioned several times the word multidisciplinarity. In environmental domain, we are multidisciplinary. I mean, the multidisciplinarity is a necessity. It's a complex system, and usually, historically speaking, we divide the entire environment in 4 different spheres: the atmosphere, radiosphere, biosphere, and geosphere. And for each of these spheres, we have different components. There is biology. You need to work together with the physicist, biologists, geologists, and so. So it's multidisciplinary per se. And then there are many things that should be considered in terms that we are, in some sense, global in scope, because, for example, there is only one atmosphere. The ocean is not only from a country. But on the other side, we have also specific local environmental aspects that we need to observe and to understand. So we need to have in mind this kind of multiple geometry. This means that if we put all the spheres together, there is a strong need for interoperability. There is a strong need to have those kind of things more coordinated together. I have to say the truth that in the last years, the research infrastructure in environmental domains are working closely together, and we see a lot of progress already done towards this direction, because it's clear that we can have a much stronger impact if we work together. And I think that this could be a sort of model that can be used also for the other domains. So I would say that each expert community should work in its own and trying to get the best, and then we go to the other layers. And if we consider the other domains, here I report the domains as we have it in S3. And for energy, we have seen already that there are specific, for example, there are something which is related to the fact that in our environmental research infrastructures, we also develop specific technologies which can be used for energy, like for wind energy or solar energy, for example, but also things which are related to carbon capture and storage verification and geothermal heating. For health and food, of course, there are a lot of things in common, ranging from food security, but also all the pollutions and the impact on food, but also things which are related to vectors for disease and parasites, genomics, and so on. And if we move to, for physics also, we have a lot of things in common which are not so much related to data, but mainly to technology. We develop technology together, and there are things which should be measured, observed in the same place. Some of our data observations can be used to correct, for example, some observations for physics. For example, this is typical for the study of space, Earth physics. And for social science. For social science, here I did not report too many things, but there are, as I said, first of all, there is the perception of the people, which is the society. That environmental challenges, environmental risks are high on the agenda, not, I would say, not the political agenda, but the agenda that everybody has every day. Now people is concerned when they go to do shopping, they don't know what to buy because of pollution and so on. There are concerns for the food, concerns for the air quality, and this has a direct impact on the everyday life. Then there are other things which are related, already mentioned yesterday and today, climate change, immigration, the things that we are now a real war, which is the environmental war, I would say. There are a lot of killed people, dead every year for pollution. And there are a lot of problems related to food production in specific areas, and the situation will not improve very fast, I would say. Actually, what we measured, exactly the opposite trend. So we should be ready to try to, I will not say, I mean, to understand and to try to do something together, because there is a strong demand for that. And then I left for the last point, the digit, the data, because data are one of the things that we have in common, and we should work more on that. So just to summarize, I would like to say two things: to consider time, to get value to the data, and to try to find the right interfaces where we can really work together at a different level. I will not put everything together in a sort of chaos, because this will not work. And this is probably my suggestion. I don't have a real solution so far, but looking forward to work with all of you. Thank you.
Thank you.